Hi everyone, Assalamualaikum. In this video, we are going to continue with example 3 under non-homogeneous equation for second order ODE. Solve the second order equation y double prime plus 4y equals to x squared plus 1 minus e to the power of 3x. This is non-homogeneous equation because right hand side not equals to 0. And this is second order ODE because we have y double prime here, or second derivative. Okay? Alright. To solve non-homogeneous equation for second order ODE, first step, we need to find the general solution yp. Okay? Alright. To find the general solution yp, we need to solve homogeneous equation. Homogeneous equation means we equate y double prime plus 4y equals to 0. Okay? So from y double prime plus 4y, we can write y double prime plus 0y prime plus 4y equals to 0. We put 0 for any missing derivative to avoid error. Okay, so that's why we put plus 0y prime here. Okay, because from the original question, there is no term containing y single prime. Okay. Alright, so from here, we need to find the characteristic equation. Characteristic equation means we replace y double prime by m squared. Okay, we replace y single prime by m, which is m to the power of 1. And we replace y by 1. 1 means m to the power of 0. So y double prime we replace by m to the power of 2. Y single prime we replace by m to the power of 1, which is m. And y we replace by m to the power of 0, which is 1. So after we substitute here, or we replace here, so we get m squared plus 0m, no need to write 0m, and then plus 4 times 1, so 4 here, okay? Alright, and after that, we need to solve quadratic equation because this is quadratic equation. Okay. So we can write m squared as a subject, which is equals to negative 4. And then m equals to plus minus square root of negative 4. If we use calculator, we get error here. Okay. But we can solve using complex numbers. Okay. We can write plus minus, we split square root of negative 4 equals to square root of positive 4 times square root of negative 1. Okay, so we get plus minus, square root of 4 is a perfect square, so we can write 2 here. And then square root of negative 1 equals to I, imaginary numbers. Okay, and from m equals to plus minus 2i, okay, because we have term containing I here, which is imaginary number, means that we have complex roots. Okay, so if we have complex root, we need to write in terms of m equals to real number 0, we put 0 here, plus minus 2i, because we want to compare with m equals to alpha plus minus beta I. So from here, when we compare, we get alpha equals to 0 and beta equals to 2. Okay, if we get complex root, we need to find the values of alpha and beta to substitute into formula. Okay. Alright, after that, we write the general solution yg based on the types of roots. Okay, the types of root is the complex roots. Okay, so from the general solution yg here, okay, for complex root, we have m equals to alpha plus minus beta I. The general solution is given by this. Okay, so we can write yg equals to e to the power of alpha x times c1 cos beta x plus c2 sin beta x. Okay, then we can replace alpha by 0 from here and beta by 2 from here. Okay, so we get yg equals to e to the power of 0x times c1 cos 2x plus c2 sin 2x. Okay, and we can simplify e to the power of 0 equals to 1. So 1 times any value equals to the original value. Okay, so we get yg equals to C1 cos 2x plus C2 sin 2x. Okay, this is our yg. So from until here, we done step 1. Okay, we find the general solution yg. Alright. Alright, now we recall back the procedure to solve non-homogeneous equation. Okay, we done step 1, find the general solution yg in the previous slide. Okay, so now we continue with step 2. Okay, step 2, find the trial solution yp. We solve non-homogeneous equation. Okay, so to solve non-homogeneous equation, okay, non-homogeneous equation means right hand side not equals to 0. Okay, so maybe some students think Rx equals to a quadratic plus constant and then minus exponential function. Okay, well, actually it's correct but a bit difficult. Instead of writing Rx equals to quadratic plus constant and minus exponential function, we better write Rx equals to quadratic and then plus exponential function. Yeah, just quadratic. Yeah, this means that we combine the constant together with the quadratic. Okay, constant here we combine together with the quadratic. Also, to avoid mistake, okay, we put plus sign here. Okay, so we can avoid mistake and to be easily differentiated. So we wrote a plus sign, not a minus sign. Okay. Alright, so to find Rx here, now we have combination between quadratic and exponential function. Yeah. So from quadratic plus exponential function here, okay. Okay, for let's say x squared plus e to the power of negative x. So x squared here means ax squared plus bx plus c. And then we continue with d e to the power of ex. Okay. So all term containing quadratic plus exponential function, we need to write ax squared plus bx plus c and then plus de to the power of the given exponent here. Okay. Alright. So from here, we can write the trial solution yp from here, okay, equals to ax squared plus bx plus c plus d e to the power of 3x. 3x here because the given question in terms of e to the power of 3x. Okay. Right. After that, we refer back from the procedure to solve non-homogeneous equation. After we find yp based on Rx, we now under step 2. Okay. After we find yp based on Rx here, okay, we need to find yp prime, means we differentiate from here. Okay. In between is plus sign, so we just differentiate one by one. Okay. We differentiate ax squared, we get 2ax. We differentiate bx, we get b. We differentiate c, constant, equals to 0, no need to write. And then we differentiate d constant, e to the power of 3x. We still have constant d in front, and then we differentiate e to the power of 3x, we get e to the power of 3x, and then 3 we put in front here. Okay, 3 here comes from when we differentiate exponent 3x. Alright. Alright, after we find yp prime, we need to find yp double prime. So we differentiate from yp prime here. We differentiate 2ax, we get 2a. We differentiate b constant, we get 0, no need to write. And then we still have constant 3d here because this is multiplication between constant and function x. Okay, so we just put constant 3d in front. And then we just differentiate e to the power of 3x. So we get e to the power of 3x times 3. And times 3, we simplify with 3d here. So we get 9d e to the power of 3x. Okay? Alright, so after we find yp double prime, we substitute, okay, yp, yp prime, and yp double prime into the given question to find the values of a, b, c, and here we also have d. Okay? Alright, so from the given question, okay, from here, we have y double prime plus 4y equals to x squared plus 1 minus e to the power of 3x. Okay, so now we replace y double prime by yp prime. Okay, we replace y by yp. Okay, and then we replace yp double prime here by 2a plus 9d e to the power of 3x, and then plus 4, and then yp we replace by a x squared plus bx plus c plus d e to the power of 3x. Okay, and after that we expand times 4 here, so we get 2a plus 9d e to the power of 3x plus we expand 4 with the function in bracket, so we get 4a x squared plus 4bx plus 4c plus 4d e to the power of 3x equals to the original right hand side here. Okay, x squared plus 1 minus e to the power of 3x. Okay, and after that we can rearrange. Okay, first term we write term containing x squared. Okay, because right hand side we have first term with x squared here, so we write first term equals to 4a x squared. Okay, and then second term we write terms containing x. Okay, so we write plus 4b here, we just rearrange. Okay, and then constant here we combine all the constant. Constant means term not containing x. Okay, so we have 2a and then plus 4c here, and then plus we combine term containing de to the power of 3x, so we get 9d e to the power of 3x plus 4d e to the power of 3x, so we get 9d plus 4d equals to 13d e to the power of 3x. And then for right hand side we still have x squared, and then there is no term containing x to the power of 1 for right hand side, but for left hand side we have term containing x, so we need to write plus 0x, okay, for right hand side. Okay, so that we can compare later. Okay, so we write x squared plus 0x because no term containing x, and then plus 1 minus e to the power of 3x. Okay, alright, after that from here we just rearrange here. Just now we put a 4ax squared in front, and then 4bx here, and then 2a we combine with 4c here, and then 9d e to the power of 3x we simplify by 4d e to the power of 3x. Okay, we just simplify, so we get 13d e to the power of x, right? Alright, from the previous slide, we stop until step 2, then we get 4ax squared plus 4bx plus 2a plus 4c plus 13d e to the power of 3x equals to x squared plus 0x plus 1 minus e to the power of 3x. Okay, then we can rewrite right hand side equals to x squared, we can write 1x squared, and then we have plus 0x here, and then plus 1 minus here means minus 1 e to the power of 3x. Okay, right, after that by comparing the coefficient of, okay, first we compare the coefficient of x squared here. Okay, and then we compare the coefficient of x, okay, here. Then we compare constant. Constant means term not containing x. And then we compare term containing the coefficient of e to the power of 3x, okay? Okay, when we compare the coefficient of x squared, okay, we get 4a equals to 1. Okay, we compare the coefficient of x squared. So we can write here 4a equals to 1. Okay, then we solve. So we get a equals to 1 over 4. Okay, and after that, we compare the coefficient of x. So we have 4b equals to 0x here. Okay, because 4b and 0 are the coefficient of x. Okay, so we can write 4b equals to 0. Okay, then we solve. So we get b equals to 0. After that, we compare constant. So we get 2a plus 4c equals to constant 1. Okay, so we can write here 2a plus 4c equals to 1. Okay, and we already get a equals to 1 over 4. So we replace here. 2 times 1 over 4 plus 4c equals to 1. And then we simplify. Okay, then we get c equals to 1 over 8. Okay. Okay, after that, we compare the coefficient of e to the power of 3x. Okay, so we get 13d, okay, equals to -1. So we can write here. Okay, then we can solve for d. We have d equals to -1 over 13. Okay. Alright, we recall back procedure to solve non-homogeneous equation. Okay, now we instead substitute yp, yp prime and yp double prime into the given question to find the values of a, b, c and d. So now we find all the values of a, b, c and d. So we can substitute the values of a, b, c, and in this case we also have d into yp. Okay, so by substituting the values of a, b, c and d into yp, okay, so yp from the previous slide we get yp equals to a x squared plus bx plus c plus d e to the power of 3x. Okay, we get yp in terms of this function because from right hand side question we have quadratic and exponential function. So ax squared plus bx plus c means quadratic function, and then plus de to the power of 3x for exponential function. And to avoid error, minus sign here, we just put plus sign. Okay. Alright. So after that, we replace a. Okay. A equals to 1 over 4. B equals to 0. Okay. C equals to 1 over 8. And D equals to -1 over 13. E to the power of 3x. Right. Then we continue with step 3. Okay. Step 3. We find the solution y. Okay. Y equals to yg plus yp. Okay. So from y equals to yg plus yp. Okay. Alright. From the previous slide, we get yg equals to c1 cos 2x plus c2 sin 2x. So we replace here. Okay. Yg equals to c1 cos 2x plus c2 sin 2x. So we write here. Okay. And then yp equals to 1 over 4x squared plus 0x plus 1 over 8 minus 1 over 13 e to the power of 3x. We don't need to write plus 0x. Okay. So we just write 1 over 4x squared plus 1 over 8 minus 1 over 13 e to the power of 3x. Right? Alright. So now we get A. We get Y. Okay, the solution. Okay, this is the final answer because the initial condition is not given. Okay, here. Okay, so this is considered the final answer. Right? Is my answer correct or wrong maybe? Okay, we can check the answer. We just use the final answer we get from the previous slide. Okay, we have y equals to c1 cos 2x plus c2 sin 2x plus 1 over 4x squared plus 1 over 8 minus 1 over 13 e to the power of 3x. Okay, so from here we need to differentiate 2 times. Okay, when we differentiate y, we have constant c1 here, so we still have constant, okay, c1, and then we differentiate cos 2x, we get negative sin 2x, then we differentiate 2x, we get negative 2 here, okay, and then we have c2 constant here, so we still have c2 when we differentiate, when constant multiply by function x, okay, so we still have constant 2 in front, and then we differentiate sin 2x, we get positive cos 2x, then we differentiate 2x, we get 2 here. Okay, and then we differentiate 1 over 4x squared using power rule. We just bring 2 in front here, so we can simplify with denominator 4, so we get 1 over 2x. And then differentiate 1 over 8 is constant, so 0, no need to write. And then we differentiate negative 1 over 13 e to the power of 3x. We still have constant negative 1 over 13. And then when we differentiate e to the power of 3x, we get e to the power of 3x. And then times 3. So 3 times negative 1 over 13. We can write 3 in numerator here. Right? After that, we differentiate again. Yeah? We find second derivative. Yeah? We differentiate from first derivative here. Yeah? So we still have constant negative 2c1. Then we differentiate sin 2x. We get cos 2x. And then differentiate 2x, we get 2. So 2 times negative 2c1, so we get negative 4c1 here. Okay, and then we still have 2c2 constant, and then we just differentiate cos 2x. So we get negative sin 2x, and then we differentiate 2x, we get 2. So we have negative 2 times 2c2, so that's why we get negative 4c2 here. And then we differentiate half x, we get half, and then we differentiate this function, so we still have constant 3 over 13, negative 3 over 13. Then we differentiate e to the power of 3x, we get e to the power of 3x, and then we differentiate exponent, so we get 3. So 3 multiplied by 3 in numerator here, so we get negative 9 over 13 e to the power of 3x. Okay. So after we find y single prime and y double prime, we substitute into the left hand side question, into here. Okay, and we need to show that the left hand side equals to right hand side, because if we show that left hand side equals to right hand side, means that the final answer is correct. Okay. Okay, so from left hand side question, we have y double prime plus 4y. So we substitute y prime here. Okay. I mean y double prime. So y double prime equals to negative 4c1 cos all of this in purple color. Okay. And then plus 4y. Okay. Y is here. Okay. And then we multiply by 4. So we get positive 4c1 cos 2x, and then positive 4c2 sin 2x, and then 4 times 1 over 4, we get 1x squared, and then 4 times 1 over 8, after simplify, we get half here, and then 4 times negative 1 over 13, we get negative 4 over 13 e to the power of 3x here. Okay. Then we simplify. Right. We arrange based on the same coefficient so that it's easy to simplify. Okay. So now the first term, we have term containing c1 cos 2x. So we can simplify negative 4 and plus 4 here. Okay. So it becomes 0. And then from the second term, we have term containing c2 sin 2x. So we can simplify negative 4 and plus 4 here. Okay. Equals to 0. And then there is no term containing x squared here, so we still have x squared here, and then half plus half equals to 1. Okay, and then negative 9 over 13 minus 4 over 13, we get negative 13 over 13, okay, which is equals to negative 1. So after we simplify, we get y double prime plus 4y equals to, this is 0, This is also 0. And then we have x squared. Okay, plus this is 1. Okay, and then negative 13 over 13 is negative 1. And then e to the power of 3x. Okay, then we double check. So from here, y double prime plus 4y equals to x squared plus 1 minus e to the power of 3x. When we compare from the original question, it is exactly the same. Okay, so means that we show that left hand side equals to right hand side. Means the final answer that we get from the previous slide is correct. Okay. Right. Coming up next, more examples for non-homogeneous equation. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.